Hello everyone, my name is Don Russell, and I am University Curator at George Mason University. I want to introduce you to an amazing public art project called Arcadia by musician Sam Nestor, and which can be experienced both live online and at Mason's hydroponic greenhouse. Today I specifically want to highlight Arcadia's role as a cross-disciplinary research platform. Art as research is a growing field within the arts, and Mason, as the country's youngest Research One university, is poised to play a significant role in advancing these efforts. Of course, all artists perform research of some kind, but more recently, artists are included as equal collaborators with scientists on such topics as climate change and sustainability. Art is a unique form of communication that fosters creative thinking, and art has untapped potential to play an integrative role in the university's learning process and in public communication across many important social issues. Arcadia is a prime example of a collaborative and cross-disciplinary work of art. By tapping into the biorhythms of plants, Sam Nestor has created a new presence for plants, letting us see and hear the beauty contained in their electrical activity. It is also a platform for further research, opening up new possibilities for interpretation across all university curricula. Today, I am extremely pleased to introduce Donnie Nolan as she discusses her Ph.D. research tracking and interpreting the live stream of data generated by Arcadia. Thanks for joining today, and we look forward to many more projects where artists play a key role in research.
Donnie Nolan, the Greenhouse and Gardens Program Manager here at the Office of Sustainability. I am taking care of the Arcadia rack and utilizing it for research. First of all, it's super cool that we get to receive energy data from the plant, where we're actually seeing them have a change in energy from being watered or being touched, or even just that human energy, actually seeing that in the data that we're collecting, and I'm able to put that into a graph, which is just super cool. So here's where we water. Definitely see the plants, they like being watered, right? Yeah. And then here's where we touch them. Oh, so cute, yes! When they got super excited, we were like touching them, and they were like, woo! They like actually responded to our energy. This is the sensor going to the graph. Isn't that so cool? They're reacting to us. I love it. Love it. Plants are sensitive to human intent. And human energy can actually, good energy can help plants grow better, faster, and help seeds germinate. So I even tell my student volunteers when they plant seeds to give them love. And here's kind of evidence that we're able to see that plants do react and experience our energy that we give them. We're also doing research with ginseng. They're very slow growing, very rare and very expensive, as you may know with ginseng. So here we've done experiments by putting them in different pots in plastic and terracotta. Now I've been told by experts that you can't grow ginseng in a greenhouse in a pot because it gets root rot. And I'm actually doing my PhD research on root rot, which is a plant disease where the roots rot. So ginseng takes years to grow, and if it's getting root rot, it's just going to die really fast. So I'd like to research that. My main research about root rot is about preventing it with beneficial microbes. So different types of soil that I've used. We're using different types of log mulch from logs in the woods. So we've taken soil from the woods and put them in pots to try and imitate the forest floor for our ginseng. And you can actually see this one is sprouting. This one has already been months growing. This is already like a 5-year-old root that's in here. And you can see it just sprouting a little bit right there. There it is. And it's looked like this for several months. They grow really slowly. I can actually see the ridges on the leaves here. They only have a few leaves, and then they do flower and create a few berries as well. But the root is what you would use for medicine. And so it's really cool. We're going to be able to put these in the Innovation Food Forest, one of our organic gardens on campus. And hopefully we'll be able to replicate them and have a lot more ginseng growing. Getting to start them here allows us to research it, use it for the Arcadia project, address the different root rot. So I've learned that the terracotta pots seem to work better, helps with a nice water balance. The plastic pots they didn't like. I tried adding different soil and that didn't work as well. So we're kind of narrowing it down to what works well for the ginseng. We also have some golden seal roots that we're growing. Again, very slow growing. You can just see a little bit of the golden root under there. These look barely any bigger than when I planted them months ago. Very, very slow growing. But really important natives that are becoming extinct, that are highly medicinal, that we need to learn about and propagate and research, especially in an accessible place like in the greenhouse here, so that we can then plant them outside where they can flourish. And it's really cool that we get to involve the Arcadia project and students. If you'd like to come and interact with the Arcadia, you can schedule a visit with us or a tour, or if you sign up to volunteer, you can always take a break and hang out with the Arcadia plants, pull up the music on your phone, and help us work in the greenhouse here while listening to our lovely plants.
So this is the data that Sam Nestor had the sensors picking up from the plants. So each MIDI controller has a certain channel. So this was 2 plants that were controlling the sound and the light. We had number 9 and 16 in this case that were running and taking data. So the plant with sensor 9 and the plant with sensor 16 together were orchestrating the music and the lights that everyone can watch live. And this is the velocity reading. You could say that it was kind of the energy or the vibration of the plant that the MIDI sensors are picking up. And this was one of the parameters that was used to interpret what note, what sound, or what kind of light was happening. So you can see where it doesn't say general purpose, it'll say a note and a number. That's actually the pitch of the music, right? In the key of C, let's say that was note C that it would play, and 4, or C sharp in this case, right here, and 4 meant the octave. So probably like kind of like middle pitch, not too low, not too high, right? If a D1 would be like a super low D, and a D8 would be like a super high. So it's really interesting to see, and these are taken like every millisecond. There's about 1,000 readings every minute. So the plants are rapidly changing the key of the music as well as the speed of the music, which is shown in this chart with velocity. And they're also controlling the lights through these same letters and numbers and the velocity rating. So you can see it jumps around a lot. There's a lot of zeros and 100s, but all these other numbers, I was able to organize it looking at one plant at a time and then looking at the velocity. So these are the numbers that I was taking so that I could easily chart it and try to interpret this data as some kind of like a feeling that the plant would get. So here I'm trying to look for a feeling from a plant, some kind of reaction. There are a lot of studies and books about the secret life of plants and how they can actually sense human intent and emotion. And I teach this to students as well. If they're sowing seeds or transplanting, you want to give them good energy. I've seen it make a huge difference. A lot of people come to me and they've never grown anything. They're thinking, I don't have a green thumb. Everything that I touch is going to die. I can't grow anything. And I tell them like, well, yeah, if you plant a seed and tell it that it's going to die and that we all suck at this, it's going to grow with that vibration. It's going to not have any hope and it's probably just going to die. You know, you wouldn't want to raise a kid telling them that. So same thing with a plant. You just got to give it some hope. If you just tell that seed, I believe in you and you're so cute and beautiful and you're going to grow up and be so strong and serve this higher purpose of feeding us and giving us beautiful flowers. And the plant is like, yes, I'm going to grow for these people and serve this higher purpose. Plants have been the primary producers of food for millennia. So I think that they appreciate being martyrs and providing for the greater good. So I do often tell plants, I'm going to eat you one day, but it's going to be great. We appreciate you doing that sacrifice. So anyway, I'm trying to sense from this data if plants are able to react to just something really quick, such as human energy, like being touched in like a really excited way or being watered when they were really, really dry, and seeing if those kind of events actually are being shown in this data. So with this chart, I was looking at watering one of the nasturtiums that was very dry. But the nasturtiums are beautiful flowers that we put in the Arcadia rack. They're my favorite. They're edible, and they're going to go into the gardens later, and they're going to grow all summer. Over the weekend, of course, they get super dry. So I went and I started collecting the data, and it's like, okay, At 12:05:52, this nasturtium was extremely dry. And then I went ahead and watered it. And so this is the reaction, right? This is what this chart is. And you can see scrolling down, it goes to 12:06. So this isn't even a minute. It's very, very quick. And here's the graph that came out of that data. So you can see along the bottom on the x-axis, we have time. It's kind of squished together, so you can't really read it, but we start at 12:05 and we end at 12:06. And then this number on the y-axis is the velocity, right? This is like the vibration of the plant that the MIDI sensor is picking up and interpreting as the speed of the music, how fast the music notes change, or how fast the lights change, or I think it actually is interpreted as the brightness of the lights. So a low velocity, the lights would be very dim, a high velocity, the lights would be very bright. And we have a lot of jumps from 0 to 100. That's what all these blue lines and white lines are. And I'm not sure why that is, but if you ignore all of the zeros and 100s, which are consistently just 0, 100, and you look at all these changing numbers, you can see how our nasturtium is around like 30 to 50, or maybe 45 to 50 when it's dry. And then there's this very obvious moment where I start to water it a few seconds into this 1 minute window. And the energy just starts to go up and the velocity keeps going up, and maybe it starts to taper down. So this shows that this plant does have a reaction to being watered, where it's actually like getting more energy. It's getting more excited, or it's having a higher vibration, right? Maybe it has a low vibration when it's dry because it's thirsty and it's kind of tired and sluggish. And then when it gets water, it's slowly being able to absorb it over this minute and actually like reacting. So here I think this is a pretty good peak, a pretty good little difference in the chart here that shows that this nasturtium was aware that it was being watered, just having more energy from being watered. I think it liked it. Of course, plants like water. Now in this next graph, I had another student there with me, and we tried touching the nasturtium, but also being like really excited and energetic. So we were like, oh, nasturtium, oh, you're so pretty, oh my God. We were like touching its leaves and stems and like being just like really obnoxious and happy and excited, and like really focusing on giving this plant love and appreciation to see how it would react differently to the watering. And it was a huge difference. So if we look at this graph, it looks very different from the other one. This is a little bit longer of a time as well. Actually, 7:49 to 17:50. Yeah, so it's still just about a minute. And we could see that the energy, the difference of the velocity is huge compared to the last chart, right? Where this is just jumping all over the place. And I think the maximum velocity is actually 128, which this plant almost reaches. And we did not see that in our other chart. We were just watering and kind of just being calm. We never got even up to 100. But here, when we're giving the plant all this energy, it is definitely sensing and responding to that energy. So you can see it goes all the way up to 120. I had never seen them get to that velocity, and it went even like below 30. So the plant's just like, ooh, ah, ooh, ah, ooh, oh, I'm getting attention. Oh my gosh. And it's doing this very like sporadic energy of like slowing down and speeding up, and just very, so it's just very different. So here is kind of my evidence that these MIDI sensors are picking up the actual plant's feelings, so to speak. Now in the scientific world, we're usually discouraged in using feeling as a plant, right? It's not that the plant likes sunlight. The plant grows better in sunlight, but really we're trying to like pivot the science to be more inclusive of the fact that the plants are actually highly aware and intelligent beings on a level that humans might not be aware of or be able to understand. And so those plants controlling the music and the lights, we really have no idea to what extent they are aware of their power. They might know and might even overhear us, and maybe they just understand without even language. They're like, oh wow, we're being broadcasted online, this is so cool, we're going to make some music, we're going to make this light show. And perhaps they're controlling it in a way, or hey, there's people doing yoga right outside there, let's like control the music and do it like this. Or right, if they sense that people are excited in the greenhouse, they are making more excited music, and lights that are changing quicker or that are brighter, to match the human energy. So I think in this case, the nasturtium appreciated, I don't know, maybe it was upset. Maybe it was like, oh, this is too much for me. Stop touching me. But I assume that the plant was actually like, oh, this is exciting. Oh my gosh. Because at least this is proof that the plant is reacting, that there's a difference here where we're just watering and it's calm to where we're really excited. I mean, this is just a very stark difference. These peaks are much more flat compared to this one. I mean, the difference in these peaks is just huge. So I'm pretty sure that our plants are reacting to us and are picking up the emotion of our students, and maybe even people who are not right at the greenhouse. If I just think about this nasturtium, I could probably track this same reaction. Me just getting all excited about the nasturtium, so that this nasturtium would be reacting in the same way. Even though I'm not there and touching it, they can actually sense like a spiritual presence, or just thinking of the plant. And there is some evidence of that. Scientists have been able to show that plants can sense when their owners are thinking about the plants, meaning that distance does not matter, that as soon as I think about the nasturtium knows I'm thinking about it in a split second, and that there's that kind of spiritual presence as well. And so we could potentially do that kind of research. We could also do research with the horticultural side, with the pests or the other growing methods or conditions, to see if the plants are happy or not. I can't really get happiness out of this data. I don't know if this nasturtium is upset or if it's excited. All I know is that there's some difference, right? I see that there's bigger peaks, that there's some change in energy from a very calm plant that is getting more energy from being watered versus a plant that is like sporadically changing its energy because we were being very energetic and interacting with it in that way. But this is definitely promising, and I would love to do more research with this and see, maybe if we were to harm the plant, obviously it's not going to be happy. And what does that chart kind of look like? And how can we maybe get some data for like happy or angry or sad, and try to see if these peaks correlate with some kind of like emotion? Because then we could say, oh, does the plant like this soil? Does it like this soil? Does it like this treatment or this treatment? Is it too much fertilizer? Is it too little? Because usually we can't tell about those issues until it's too late. And then we see, oh, there's like 100 pests on this plant. Oh, it is now showing symptoms of a fertilizer deficiency because it's been that much of a problem that we're now seeing symptoms of it. So being able to get that information early might be very helpful. And potentially even like plant therapeutics is a possibility. I'm not sure. I could dream very big about where to take this, but I think that's kind of the concept of the Arcadia, is that the plants are reacting to us, and that we want to interact with them, and that we want to see the evidence that they are responding to us, and that they are aware of us, and that they actually will match our energy. And that's just really cool. So yeah, thanks for listening.